All right, so just so you know, this is now recording so that I'm hoping if this works to post the 3 examples up later as something that you guys can go back and look at. So we are going to look at word problems and how they relate to linear equations. This is not, whoops, try that again. This is not any different really than when we've done word problems in the past. And by that I mean we're still going to be pulling out key information. We're still going to be looking for an equation. Okay, so for example 1, suppose that the water level of a river is 34 feet and that it is receding at a rate of 0.5 feet per day. Write an equation for the water level L after D days. So we know we've got these 2 variables. And how many days will the water level be 26 feet? So in the chat, what are some key pieces of information that we need from that word problem? All right, so we need the 26 feet. And what is the 26 feet? I don't want to just write 26 feet. That's what we want to know. And how many days will the water level be 26 feet? So that's kind of like our end. That's where we're going to go. Okay, we've got 34 feet. People are saying in the chat. Again, 34 is a very nice number, but what does it mean? It's 30 feet right now. So that's where we're starting. So we're starting at 34. We're going to end at 26 feet. Someone put in the chat the 0.5 feet. And that's what's going per day. Now, is it going up or down 0.5 feet per day? Yeah, you need this word right here, receding. And that's why I try to avoid just the use of keywords all the time, because this is not any keyword that we would have ever put into a table for you guys to go, here are keywords to look for. And yet it's really important to this word problem. That tells us that it is going down. Okay. And what's the thing that we don't know? We're looking for how many days. Good. So that's going to be our D that gave us is how many days. Specifically, how many days it takes to get down to 26. Okay. So over here, one of the things I always tried to teach you guys in our last unit was don't just try to start writing the equation. Think about what's happening. We are starting with a river at 1 water level, right? The water level is going down by some number of feet per day. And then it's going to stop at the ending point, right? We're starting at 34. We're going down 0.5 feet per day. Well, we don't know how many days it's going to take, so that's our D. And we'll know we're done when we are at 26. There's our equation. Is that a linear equation? It sure is. All right. We didn't have X's and Y's, but this would be a linear equation. We might not know where it ends, but we could say a number minus something X equals our ending point, our Y. Now we happen to know what our ending point is, so we replaced it with the 26. How would we go about solving this? What are we going to get rid of first?
The 34.
Let's get rid of the 34. So we're going to do the opposite. That is a positive 34. So this goes back to our first unit. And I have a negative 0.5D. Got to remember that negative there equals a negative 8. And then we divide both sides by negative 0.5. And we get D equals, anyone know what that is? Nope, that would be 8 divided by 2. We're dividing by a half. So it's actually going to take more.
It's going to be 16.
It is going to be 16. Because it takes 2 halves to get to 1, and we're getting all the way up to 8. So it's going to take 16 of them. And those 16, since D was how many days, are 16
Days.
All right. Let's try the next one. Anybody have questions on that one before I go to the next one? Pretty similar to what we were doing, right? All right, so example 2. For babysitting, Nicole charges a flat fee of $3 plus $5 per hour. So in other words, it's $3 to show up and $5 per hour. I wish I had done that when I was in high school. I babysat for this kid for a while, and I would have to ride the bus all the way around to get to their house and then walk down a half-mile dirt road. I'm not kidding you. I know it sounds like a lie. To get to their house. And then half the time I would get there and the dad would be there and say, "Oh, never mind. I'm going to be home today. I'll go ahead and bring you home." And I was so upset because I'd ride that bus for an extra half hour and I'd walk down a half-mile road and I got paid nothing for it.
That's not fair.
And I did that like 3 times a week. So this person, Nicole, has made sure that that's not going to happen to her. She's charging you just for showing up, right? And then $5 per hour after that. So we want to write an equation for the cost after 8 hours of babysitting. So what is it going to cost someone for however number of hours Nicole is there? Okay. So what are some things that we know? Okay, so we got that flat fee of $3. No matter what, she's getting paid $3. Probably should update this with some more realistic numbers from these days. And she's getting $5. People said per hour. All right. And we've got another variable, right? We've got C, we want to know the total cost. Now this extra part down here about the 5 hours, that comes later. First, it just says, what do you think the slope and the y-intercept represent? So we're going to put this into an equation, okay? We don't know the number of hours that she might babysit. We will after we're going to do the 5. So if you think about it, she gets her flat fee, right? Plus her $5 per hour, and that will give you the total cost. Well, what was her flat fee? It was $3. And the $5 per
Hour.
each hour gives us our total cost. This is a linear equation. And it is a little linear equation that we could use to figure out how much she's going to get paid for any number of hours, right? 1 hour means she would get 1/5 plus the 3. 2 hours means she'd get 2/5 plus the 3. 3 hours means she'd get 3/5 plus the 3. Which of those numbers is our slope?
The 5.
Okay. So the 5 is going to be our slope because that's the thing that is changing, right? 1 5, 2 5s, 3 5s, 4 5s. That's causing our line to go up. That means this 3 is going to be our y-intercept.
So the number that's going up or down is going to be your slope.
Yep, it's the thing that's changing, right? So if we think about graphing this, right, no matter what, even if she works 0 hours, she makes $3. So we start at 3. There's our y-intercept. And then for every hour that she works, we got to go up $5. So that's our slope. So we could graph that line and we'd see she starts at 3 and then she gets $5 going up. Now, technically, real world, we would not have a line down here because she can't work negative hours. All right. Now, the second part of that question was, okay, how much money will she make if she babysits for 5 hours? So where's that 5 going to go? It's going to go in for the h. You know, kind of like when we have f of x equals something and we replace the x. Just saying. And so this is going to be 25 plus 3 is 28. So she would make $28. All right. Are we okay? It's better that you remember the word problems being the first time. See, you're making connections in your head. Your brain cells are making new pathways. So last one. Rufus collected 100 pounds of aluminum cans to recycle. Can we all agree that kind of sounds like it's going to be something that we probably need to know? So he's got 100 pounds. He plans to collect an additional 25 pounds each week. So he is going to add 25 pounds per week. Write and graph the equation for the total pounds, P, even though pounds is LBS, of aluminum after week W. Okay, so what did he start with?
The 100 pounds.
So we have the 100. And then Jonas, what are we adding to the 100? The 25. Are we only adding 25 once? We're going to add it every single week, right? So 25 for each week until, and that will give us the total number of pounds. A linear equation.
So it's kind of like you're doing the linear equation before you actually kind of try to solve that equation.
Because by doing a linear equation first, we can answer all kinds of questions. We can pick any number of weeks to put in here to figure out how many pounds he'd have collected. Or we could put in some total number of pounds to figure out how long it will take. Okay, this is our slope. This is our y-intercept. So if we graphed it, we would have a y-intercept way up here at 100. And then it would go really steeply up 25 and over 1. Okay, so now the question was, how long will it take Rufus to collect 400 pounds? So where am I going to put that 400? Is that going to go in for W or is that going to go in for P? Bingo. So we got the 100 plus the 25W has to equal the 400. And so we subtract the 100 and we get 25W equals 300. And we divide both sides by 25. And we get W equals 12 weeks. Now, really quickly, before I let you loose to try some, I am going to pull up Desmos because we love Desmos. And I'm going to say 100 plus 25W equals P. I'm not sure if it'll graph it with W's and P's. So let me just see if it will. We might have to change it to X's and Y's. I'm going to zoom out because those are some big numbers and I don't see anything. And you see how it's got the exclamation point there? Can only do X's and Y's. So the W is going to become, which one? W is going to become our X. P is going to become our Y, right? And there we can see it now. Really steep line because it's going up by 25s. Crosses up here at 100. Okay, there's our y-intercept. Going up 25 by 1. Now remember, it said, what is it going to be when our y is 400? So could I come up until I get to my y is 400 and come over to my line? And I gotta find it. Usually Desmos is better about that. But I'm not exactly on, but can you see how it's right about the 12? So when the pounds are 400, oh, there it is. The weeks are 12. All right. Any questions? Okay. Then I'm going to stop my share. Also going to stop my